Hi everyone, welcome to Homeschooling SAT Prep channel. Today we are going to start part 2 of rate chapter. In this video we are going to cover, in the part 2 we will cover speed, time and distance. In part 1 we have covered unit problems and time and work problem. And at the end I've given you 5 practice problems. I hope you have watched part 1 and solve these 5 practice questions. In this video in part 2, first we will take some basics of speed, time and distance. Then we will solve 10 numerical problems related to speed, time and distance. And there will be few previous year questions also in these 10 problems. And at the end, I'll give you 5 practice problems, which you have to solve by yourself and answer those questions in the comment section below. If you want to seriously prepare for SAT exam, you can check out our various courses at Homeschooling app and website at a very affordable price. All the links are provided in the description below. Now, coming to the basics of speed, time and distance. So the basic formula of speed, time and distance is speed is equal to distance upon time. So from this formula, by using cross multiplication, we can move speed here and time here. So time is distance upon speed. And if you have to find the distance, so distance, and we'll multiply these two. So the distance is speed into time. There is another way to remember this formula. So this is your pyramid here. As you can see, at the we will divide it into two sections, and the lower section will be divided into two sections. So at the top is your distance, d, speed, and time. So if you have to find the distance, that is, so as you can see, speed and time is there, so we will multiply them. So this is one way to remember this, because distance is at the top and speed and time is at the bottom, so we'll multiply them. If you have to find the time, so as we can see, distance is at the top of the pyramid and speed is at the bottom, so we will write distance at the numerator and your speed at the denominator. So time is equal to distance, that is the top, will be on the numerator, and speed, that is at the bottom of the pyramid, will be in the denominator. Similarly, if we have to find speed, so at the top speed is there, and at the numerator, sorry, at the top distance is there, so we'll put distance in the numerator, and at the bottom of the pyramid time is there, so we'll put time in the denominator. So I hope you can remember this pyramid or this formula, or you can remember just this formula, and by cross multiplying you can find time and distance. Similarly, or you can remember this pyramid, d and s and t, d for distance, s s is speed, t, so dst pyramid, you can remember this and you can find the formula. So these are the two ways to remember these formula. Now let's move on to the average speed. Let's say this is point A. Let's say it's your home at point A, and this is your B at point B. It's your work there, workplace. So you go from home to, and let's say the distance between these two are 10 miles. So if distance is same, because if we go from home to work and we from work, come back from work back to home, then we will cover the same distance because distance will remain constant. Let's say in morning at 9 or 10 o'clock, there was a lot of traffic, so your speed was 20 miles per hour. 20 miles per hour. While returning uh, at 9 or 10 o'clock at the night, the roads were empty, so you were driving in the city at a speed of, let's say, 50 miles per hour. So what is going to be the average speed? So the formula for the average speed is when the distance is equal. Remember, for the formula for average speed is 2 into x into y divided by x plus y. So This will be 2 into 20 into 50 by 50 plus 20. So that is 70. So this one would be how much? 2 into this one would be 20 into 50 would be 1000, and this one would be 70. So this will go. So 200 divided by 7 will be your average speed in miles per hour. You have to remember when this average speed formula, when distance is same, when distance is same. So the average speed formula is 2 into x into y divided by x plus y. Now let's take one more case here. So let's say the whole journey was, that whole distance is 10 miles. So let's say this one is 0, this is the starting, this is your 10, and this is the center. Okay, so here this car travels, so 5 is the center, so this is the center or middle distance. So from here to here the distance would be 5 miles, and from here to here the distance would be 5 miles. So as we can see that, as we can see the property that the distance is equal, and the car is traveling at a and b miles per hour. So we can use the same formula because the distance is distance between bet, traveled by both the cars are same. So we can use the same formula. Here it is written in 2xy term, so here it is written 2ab by ab. So always remember, we can use this formula, average speed is equal to 2xy divided by x plus y, when they are coming from one place and going to one place and coming back to the same place again, and so the distance would be same. Or when someone is traveling, first they travel half of the distance at a particular speed, then they cover the rest of the half of the distance at a particular speed. So in those two conditions, we can use this average speed formula. Now let's take another case here. Let's say this is your starting point, 0 mile. This is your end point, this is 10 miles. Let's say this is your so, journey one start from 0 to third miles, and at a speed of x miles per hour. And after 3 to 10 miles, so he covered rest 7 miles at y miles per hour. So here, as we can see, the distance is different because from here to here it is only 3 miles, and from 3 to 7 it is 7 miles. So the difference is uh, so the uh, distance is different. But this car, when it is traveling from 0 to 3 miles, it covers in 1 hour, and this one is traveling from 3 to 10 miles, that is 7 miles. They cover this 7 miles distance in 1 hour. So this speed would be higher. So for when we have that kind of condition, then what we are going to have, when we have different distance but time is same, so the formula would be x plus y divided by 2. Let's take one more example here. Let's say there's one more car here. Okay, so x, y, z miles per hour, but it starts from 7 miles to 10 miles, so it is covering only 3 miles. So all the three cars cover their distance. All the three cars cover their distance in 1 hour. So we have different distances. So distance, first car for journey is covering 3, 7, and last one is also covering 3 miles, and all of them are covering in 1 hour. So what is going to be the formula? So here your formula would be x miles plus y miles plus z miles divided by 3. So that is going to be your average speed. So now, because all of them are having same time, but the distance is different, and so the average formula speed would be for 3 would be x plus y plus, because it is average speed of all these three cars. So you have to remember that if four cars would be there, so x plus z, y plus z plus, let's say one more term is there, uh, o. So o miles per hour. So this will be 4. So whatever, we will add all the speed and divided by the number of cars, or the number of cars, that is 4. If there are 3 cars, so 3. If there are only 2 cars, so 2. So this is the basic of average speed. Mostly you will get questions either from this one or this case. Now some basics which you have to remember. Uh, in 1 mile you have 1.609 kilometer. So you can, for to remember, you can just remember 1.6 kilometer. In 1 kilometer you have 1000 meter, and in 1 meter you have 100 centimeter. And in 1 centimeter, how many millimeters are there? And in 1 centimeter there is 10 millimeter or mm. Similarly, this was your distance. So for time, 1 hour has 60 minutes, and in 1 minute you have 60 seconds. So in 1 hour would be how much? 1 hour would be 16 to 60, that is 3600 seconds. So sometime in question, instead of the time is given in hours, because speed, if you have to find speed is most of the time it is given in uh, the question is asked in kilometer per hour or miles per hour. But sometime in the question, the time is given in a minutes form. So let's say the time is given 10 minutes. So, but in the question, we have to find the speed in miles per hour or kilometer per hour. So we have to convert those minutes into hour. So how we can do that? So whatever the minute is given, 10 divided by 60. If 5 minutes is given, so 5 divided by 60, so that is 1 by 6 hour. So 10 minutes is equal to 1 by 6, 1 by 6 of an hour. One more thing that you have to remember here is, till now they haven't asked these types of questions, that to convert kilometer per hour into meter per second, or meter per second into kilometer per hour. But to remember that you have to convert kilometer per hour into meter per second, you have to multiply it by 5 divided by 18. And to convert meter per second to kilometer per hour, you have to multiply 18 divided by 5. So you have to remember this. They might ask, because in 2024 the digital SAT syllabus has changed, and a lot of different type of questions are being asked in last 2-3 SAT exams. So we might expect questions from kilometer per hour to convert that into meter per second. Now let's move on to the questions now. Question number 1 says that SpaceX rocket travels 60 miles in first 5 minutes after takeoff. What is the average speed of rocket in miles per hour? So we have to remember, we have to find speed in miles per hour. So what is we'll write the data that is given in the question. So first, it travels 60 miles. So the distance would be d. Your distance would be 60 miles in first 5 minutes. So time is t is 5 minutes. So we have to find what? We have to find average speed. So average speed. As we know, speed is equal to distance upon time. So your average speed is equal to, see, we we have to find average speed in miles per hour. So distance is already in miles, but your time is not in mile. Sorry, your time is not in hour. It is in minutes. So as we know that In 1 hour, there is 60 minutes. So to convert minute into hour, we will divide 5 divided by 60. So that is your hour. So now what we're gonna do here is to find average speed. Speed is equal to distance upon time. So distance is how much? Distance is 60 upon time. So time, we have converted it into hour because average speed is in miles per hour. So we have to convert it into hour. So we will write 5 divided by 60. So this one would be 60 into 60 divided by 5. So 12 5 times 60, and 12 into 6 72, and we'll put the 0. 720 miles per hour. So option C is your correct answer. Now let's move on to the next question. Question says that Joshua traveled from city A to city B in 4 hours. So let's say this is your city A and he traveled to city B in 4 hours. So this is total 4 hours. The time to travel from city A to B is 4 hours. So for first hour, let's say this is your first hour, this is your second hour, this is your third, and this is your fourth hour. So for first hour, he drove at a constant speed of. So if he's for first hour he drove at 50 miles per hour. Then for next 3 hours he drove for 60 miles per hour. So now let's find the distance. So distance is the for distance for first hour. As we know, distance is equal to speed into time, because speed is equal to distance upon time. So we can write that distance is equal to speed upon time. So first hour distance would be how much? That is, speed is 50 miles per hour and it is covering that into 1 hour. So that is going to be 50 miles. Then distance for next 3 hour. So it has a constant speed of 50 miles, sorry, 60 miles per hour. So in 1 hour, it will, so we will use the formula, this formula. So the speed is how much? 60, and the time taken is 3. So the distance would be how much? 180 miles. 180 miles. So total distance, so total distance would be how much? 180 plus 50, that would be 230 miles. So now we know the total distance, and in the question it was already given that the total time was 1 plus 3 hour, that is 4 hours. So we know the total time and total distance, so now we can find the average speed. So average speed S is equal to total distance by total time. So total distance is 230 and total time is 1 hour, then in 3 hours. And it was also given that the total distance from city A to B was covered in 4 hours. So 1 plus 3, that is 4. So let me put it on my calculator. This is going to be a 57.5. So this is your answer. Option C is your correct answer. So this is one way to approach it. There's one more way to approach it. As we know, speed is equal to distance upon time. So in first hour, it it has a speed of 50 miles. So in 1 hour, so it will cover 50 miles distance. Then in next 3 hours, it's traveled at a speed of 60 miles. So so that means in every hour it will cover 60 miles, 60 miles, and 60 miles. So when you put the distance here, 50 plus 60 plus 60 plus 60, divided by the total time, that is 4 hours. So if you calculate this, it will come 6 into 3, 180, and 50, 230 divided by 4. So 57.5. So this is your shortcut method, and this is your normal method. You can approach this question by both the method. This will consume less time because you're doing a lot of thing in your mind. Instead of writing here, you are doing all those things here in your mind to find the total distance. So we are just found here. So this is how you're going to approach it. Now move in. Now let's move on to the next question. Question number 3 says that Stephen traveled from city X to Y. So this is your city X and this is your city Y. This is your X and this is your Y. So first half of the way he drove at a speed of, so let's say this is your X and this is your Y and Z is the center between the, so first half he drove at a speed of 40 miles per hour. Then he increased his speed and traveled the remaining distance at 50 miles per hour. So half of the distance he covered for 40 at a speed of 40 miles per hour and remaining half at 50 miles per hour. So we have to find what is the average speed for this trip. So as we have read in the basics that when a person is traveling half of the distance at a particular speed and the later half at another speed, so the formula would be what? Average speed formula. We have read that in the basic, that is 2xy divided by x plus y. So we'll take this one as x, this one as y, small y, this one small. So what would 2 into 40 into 50 divided by 40 plus 50. We have read this formula in the basics. So this one would be 2 into 40 by 50 divided by 90. So this one would be 400, 880 into 5, that would be 400 divided by 9. So your answer would be, let me put it on my calculator. It is, the answer would be 44.44. So this is in your decimal form and this is your mixed fraction. This is your 44, 4 by 9. So this is a mixed fraction. So what we're going to do here is 44 is constant and this will divide it and we'll find it. So when we divide 4 by 9, it comes 4444. So this is going to be an answer. Now let's move on to, so this is your answer. So 44, 4 by 9 is your answer. Now let's move on to the next question. This question says that Joe drive his car from home to his relative house at a speed of 60 miles per hour. Okay, so let's home. This is your home. This is your relative's house. He goes from here to here at 60 miles per hour. On his way back home, he drives at a constant speed, but when he is returning back to his home, he drives at 40 miles per hour. It took him, he took 6 hours for his entire journey. So this is important. You have to find, this is the perfect information that is given in you. So going this way and coming that back to home, going to relative house. So these two times, so time going from home to relative's house and relative house back to home, cumulatively it takes 6 hours. So this is a very important data that is provided in the, so what we can say that T total is equal to T to going to relative house plus time coming to home, back to home. So in the question, it is already given that going there and coming back, the total time it takes is 6 hours. As we already know, speed is equal to distance upon time. So time can be written as distance upon speed. Now let's write down all the data here. I'm doing this so that you can grab the concept. So let's say this is your time, this is your speed, and this is your distance. And we can say that it's your speed, time, and distance. And we can also write when we're going to two relative house and back home. So let's keep this as TR and this is your T home. TR for relative, T home. Now the speed that is when we are going to relative house is 60 miles per hour. So 60 miles. When we are coming back to home, it is 40 miles per hour, mph, mph. We don't know the distance. So let's, because see, we are going from here to here, home to relative's house. So if we take that as, let the distance be d, so when we return back we'll cover the same distance, so both the distance would be d. If we take one distance as d, both the distance would be d. Now let's put the formula here. So t is equal to d by s. So distance is distance, and for relative speed is how much? Relative speed is 60 miles per hour. And now time for back to home, so time is distance upon speed, so back to home distance is d and the speed was 40. Now we are going to solve this question, and so the LCM of 60 and 40 would be 60 and 40 would be first 10, 6 and 4 times, then 2, 3 and 2. So 6 into 2, 12 into 10. So 120 is your LCM. So this will go 2D plus 3D. So we can say that 6 into 120 is equal to 5D. Hence D would be 6 into 120 divided by 5. So this will go 7 times 4. This, let me see everything is correct or not. So this will go 5, no, sorry, I made a mistake here. It will not go, it will go 2 times, then 24 times. So this will be 24. So 24 into 4, that is 144 miles. So now many of you will, you know, answer or tick or choose this option, but this is not your option, because in the question it is said that what is the distance in kilometers. So this is in your miles. So miles can be converted into kilometer. So 144 into 1.609, because as we know 1 mile is equal to 1.609 kilometers. So this one would be somewhere around, because we have to find the approx value. So let me put it on my calculator. So it will be somewhere around 231 kilometers. So we have converted miles to kilometer by multiplying it by 1.609. or you can just multiply by 1.6. So this is your answer, 231. So now many of you will answer this option, but still this answer is not correct, because here we have to find the round trip. So this is the distance from H home to relative's house. So one side distance is 231 kilometers. So we have to find the round trip. So 231 from home to relative's house, then back to home, 231 kilometers. So what? So round trip distance would be how much? 231 into 2. So that would be 462 kilometers. So that is your answer. So now this option D is your correct answer. Now let's move on to the next question. The question says that John rode his bicycle to town at the rate of 15 miles per hour. So let's put it on the table, all the data on the table one by one. So speed, or see here rate is given. So rate or speed is same thing. So speed and time is equal to distance. We know this formula because speed is equal to distance upon time. So we'll take distance this side and multiply speed into time, so we can derive this form. Now we will put, we are going from riding to town and walk back home. So we have these datas here. Now we'll read the question and put all the datas here. So John rode the bicycle to the town. So from home to town. He rode the bicycle at the rate or the speed that is 15 miles per hour. He left the bicycle in the town for minor repair. Okay, and walk home alone at the same route. So remember the distance, he's walking back, so he's going from here and walking the same distance back, and walk along the same route at a rate of 3 miles per hour. So walking back speed is, when he's walking back to home, is the speed is 3 miles per hour. Excluding the repair time, the trip took 3 hours. So going from home to town and walking back from town to home, both it took 3 hours. So going from here and coming back both took 3 hours. So let's say that from here to here we are going 3 hours. Sorry, x hours. So let's keep that as x. So when we walk back, because the total time is 3, going from home to town and coming back, walking back from town to home, both both the distance are covered in 3 hours. So if we take this going this covering this distance in x hours, let's say if we take this as, so this one would be 3 minus x hours, and if we add them, this will be 3 hours. If we add them, this will be, because x and minus x would get cancelled. So now, as we know, distance, because from this formula we can say that distance is equal to speed into time. So what is going to be your distance? 15x. And what is your, this is your total time, and here your distance would be 3 into 3 minus x. So as we know that distance going from home to town is equal to distance when he's walking back from town to home. So both the distance are equal. So distance from home to town and distance from town to home are equal. So now we will put both the, will from here, because we know the distance from riding to town home to town, that is 15x. So 15x equal, then walking back from town to home, the distance is 3 minus x. Now we are going to solve it and we'll find our answer. 9 minus 3x. This is going to be, if we take minus 3x, so it will be plus 3x. So 8x is equal to 9. So x is equal to 9 by 18. That is 1 by 2 r. Sorry, distance. X is equal to 1 by 2. So in the question, because here we have excluded the repair time. So in the question, it says that the trip took 3 hours. So how many hours John take to walk back? So walking back, the time was 3 minus like time to walk back by John. So that is 3 minus x. So 3 minus half would be 2.5. So 2.5 hours is your answer. 2.5 hours. So option D is your correct answer. This one was a nice question. So whenever you are solving the re see, you have to write all the data properly and see which one is constant here. In previous question, the time was properly given. Here, the distance from going from here, home to town and town to home is equal. So from that we can, so always write down all the data that is given. So it would be easy for you to solve and see what is what information that is provided in the question which we can use to solve the question. So here the distance, both the distance are equal. In previous question, the time was given from going and coming back. It was taking 6 hours in this question. So we have to find that data and form an equation from them. Now let's move on to the next question. So what we're gonna do here, we're gonna do the same step here. Speed, and this is time, is equal to distance. You know this formula? Because speed is equal to distance upon time, so we can, distance is equal to speed into time. So what we want to do right here is, so there are two types of train, freight train and passenger train. So freight and passenger. Now, now we'll write all the data here. A freight train left the station at 12 noon. So let's say this is your station S and this is 12 noon, that is 12 p.m. Okay. He is going north. North is in this direction. This is your freight train which carry goods at a speed of 50 miles per hour. Okay. So we don't know, he has covered this 50 miles per hour distance and how much distance they are covering. So this is your freight train, and at 1 a.m. So this is 12. He started at 12 a.m. and this freight train started at 12 a.m. and this is your station. Similarly, at 1 a.m., a passenger train left the same station. This is your station S. Passenger train left the same station going south at a speed of 60 miles per hour. So always remember, rate means speed. So the passenger train, it is going 60 miles per hour. This is your station. This is a passenger train, and it started its journey at what time? At 1 p.m. So 1 hour after the freight train. So at what time these trains are 380 miles apart. So at what time and how many hours these two trains are traveling in opposite direction? So the distance between them is 380 miles. So now we are going to put all the data here. So the free train travel 12 noon at a rate of 50 miles per hour. So this is 50 miles per hour. Okay. Uh, at two. And passenger train speed is 60 miles per hour. See here we can see that free train started traveling at 1 hour before. So if passenger train takes X hours, see because free train started traveling at 12 noon and passenger train started traveling 1 hour after. So if passenger train takes X hour, so then free train, because it started traveling 1 hour before, so then it will take 1 hour more. So whatever the distance, so X plus 1. I hope you are getting it because free train started traveling 1 hour before. That's why we are adding 1 hour. And we don't know how long they have covered, for how many hours they have traveled this distance to be apart for 380 miles. We don't know that. So we have taken passenger as X and freight as X plus 1 because free train started traveling 1 hour before. So what is going to be your distance? So 50, because distance is equal to speed into time. So this one would be, no, 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 sorry. I made a mistake here. I made a mistake here. Mm, who is traveling at what speed? No, no. Okay, this is fine. Both of them are correct. So this one can be written as 50x plus 1, and this distance is equal to speed into time. So distance traveled by passenger is how much? 60 into x. That is 60x. And in the question it is said that they are 380 miles apart. So the distance traveled by both of them is 380 miles. So at the when train is here and when train is here after few hours, we don't know what the time was, for how long they have traveled. This x we don't know. So both the distance, if we sum them, then they will be 380 miles apart. So what we're gonna do here is distance of freight plus distance of passenger is equal to 380 miles. So distance of freight is 50x plus 50x plus 1, and distance traveled by passenger, that is 60x, is equal to 380. So 50x plus 50 plus 60x is equal to 380. So we'll take plus 50 on that side, that will be minus 50. So 380 minus 50, that would be 330, and 50x plus 60x, that would be 110x. So x would be 330 by 110, that would be 3. So x is a 3. So what would be time here? So free train will travel for 3 plus 1, that would be 4 hours, and passenger train will travel for 3 hours. So what we have to find here in the question, at what time these trains are 180 miles apart. So we can take any train. So passenger train started at 1 p.m. and it covered that distance in 3 hours. So 1 p.m. plus 3 hours. So 1 p.m. plus 3 hours, that would be equal to 4 p.m. 1 plus 3 hours, that would be 4 p.m. That is your answer. So 4 p.m. Similarly, we can do the same for free train, because free train started at 12 noon 12 p.m. and the time taken by him to cover a particular distance was 4. So plus 4 hours, so that would be 4 p.m. So 4 p.m. is your answer. Now let's move on to the next question. Question number 7 says that a speedboat is traveling the length of a lake in quarter of an hour less time than it took while traveling at 12 miles per hour. So he's saying that the time taken traveling at 18 miles and 12, that uh, the difference in the time at these two speeds is 1/4 of an hour. So what we're gonna write here is t 12 miles per hour, t 12 miles per hour minus t 18 miles per hour is equal. uh, then how much time is it will take? That is, it will say 1/4 of an hour. So now we have to, as we know, t is equal to distance upon speed. So now let's put all the data: speed, time, and this is your distance. So speed is 18 miles per hour. This one is 12. Let's say t12, sorry, t18. Let's keep the head. Let t12, okay. And your distance, let's take it as d, both of them. Now let's put this formula here. T is equal to time is equal to distance upon speed. So the distance is d for t12. Distance is d and speed is 12. So 12 minus d for time 12, time t18. So time 18, the speed, so distance is d and the speed is 18. So 1/18 is equal to 1/4. Because they saved, it took 1/4 of an hour less. A quarter means 1/4 of an hour less. So now we are going to factorize them. So 12 and 18, let's find their LCM. 12 and 18, 2 times 6, 9, 3, 2, 3. So 3 into 6, 6 into 6, 36. So 2d, sorry, 3d minus d is equal to 1/4. So d, so 36 is there. So we can cancel them. So that would be 9. So d, 2d minus d, sorry, 3d. This one would be 2d, sorry. I made a mistake here. 3d minus 2d. So that would be d, and 9 is equal to 1. So d is equal to 9 miles. Sorry, I made a mistake here in the question. What is the length of lake in miles? Not miles per hour. The question should be miles. So what is the length of lake? So the distance of lake is how much? 9 miles. So this is your answer. So option C is your correct answer. Now let's move on to the next question. Joshua drove to Seaport to pick up her mother. So this is his home, Joshua's home, and he go to a seaport. That's a seaport, home and seaport. A thunderstorm forced him to drive at an average speed of how much? 45 miles. Sorry, yeah, this should be seaport. 45 miles, reaching the seaport in 3 hours. So from home to the distance was 45 miles per hour, and he's reaching in how much? 3 hours. He drove back. when drove back from seaport to home, he, he drove back home at an average speed of 55 miles per hour. 55 miles per hour. So what is the time, approx time he took? So we have to find what is the time here from coming back from seaport back to home. So in the first part of the question, it is said that from going from home to seaport, as we know, speed is equal to distance upon time. So the time is can be written as distance upon speed. So sorry. Now distance can be written as speed into time. So from going from home to seaport, as we can see that speed is already given, that is 45, and time it took was 3. So time was 3, 45 into 3. So the distance from home and seaport is how much? 45 into 3, that is 135 miles. So now we know the distance from home to seaport. So that is 135 miles. So when we came back from seaport to home, we'll cover the same distance, that is 135 miles. So now we can find the time. So time is equal to distance upon speed. So distance we have already know, because from going from home to sea, if it is 135 miles, so coming back would be also 135 miles. So 135 miles, and your speed was how much? 55 miles per hour. So if you divide it, so it would be somewhere around 2.46 something. So it would be somewhere around 2.5. So we have to find the approximate time for coming back home. So it was somewhere around 2.467. So that is nearest to 2.5. So option B is your correct answer. Now let's move on to the next question. This one is a nice question, a very good question. The question says that Stephen covers a certain distance between home and work on a bicycle. Okay. Having an average speed, let's say he has to reach office, let's say he has to reach at work at 10 a.m. So this is the time. If he drove if he drove his bicycle at a speed of 30 miles per hour, then he was late by how much? 10 minutes. So the time he has to reach was around 10 a.m. But when he was driving at 30 miles per hour, sorry, no, he was late by 10 minutes. So 30 miles per hour, he was late by 10 minutes. That would be, so if he reach 10 minutes late, that would be 10 a.m. was the reaching time, but he was late by 10 minutes, so that would be 10:10 a.m. Okay. However, if he traveled at a speed of 40 miles per hour, so if he traveled at a 40 miles per hour, he reached the work how much time? 5 minutes earlier. So 5 minutes earlier to 10 a.m. would be how much? 9:55. So these are your time difference. So from this you can say that the total time difference, if he from 30 miles, if he increases time uh, to 40, then the time difference would be how much? From 10 a.m. to 9:55, that is 15 minutes. So your time would be how much? 15 minutes, because these two has a time gap of 9:55 to 10 a.m. is 15 minutes. So we can convert time 15 minutes into hours, so by 5 divided by 60 hour. We know that's to convert minute into hour, we divide it by 60. So now we can take this equation as speed is equal to distance upon time. So time is equal to distance upon speed. So the distance, let's keep the distance as d and 30, because when he was traveling at 30, first he was traveling at 30, and then later he was traveling at 40, and the time difference was how much? 15 minutes. So 15 by 60. So what we are doing here is t difference is equal to t 30 miles minus t 40 miles. And as we know, t is equal to distance upon speed, so we will put their respective distance and speed. So this will come. So this is our equation. So now we are going to simplify this equation. This is 1 by 4, and this side it is going to be 120 will be your LCM. So this would be third 40. Sorry, this one would be because 40 miles, because you are reaching here at 40 miles. So so this will come before, and this will be lesser. So 40 minus 30. So 30 minus 40, or 40, sorry, no. 30 minus 40. So it will go 4 times. 4d minus 3d is equal to 1 by 4. So d, we can, it will go 30 times. So d is equal to 30. Yes, 30 miles. So your answer would be 30 miles. So this is your answer. So what we are doing here is he has to reach at, let's say, 10 a.m. But when he traveled at 30, he was late by 30 miles. So he reached at 10 minutes late, that is 10 a.m. And when he was driving at a faster speed, he reached 5 minutes earlier, that is 9:55. So the time difference between these two was 15 minutes. So we use this equation, time difference, T30, T40, and we've put all the formulas, and at the end we found out the distance was what? 30 miles. So option C is your correct answer. So this is one type of question. See, here it was, for one speed it was late, and other speed it was early. So what we gonna do here is, when late plus early, and what we're gonna do here is we will add there. If you're not able to get this concept, just remember this thing: late plus early, we will add both the time. So 10 plus 5 minutes, that is your 15 minutes. So we have found 15 minutes. Or if one is early plus late, the first one was early, then second one, then same thing, addition will happen. So for these two, addition of time will happen. Okay, that is 10 plus 5, so it was still 15 minutes. But instead of late, one is late and one is early, if both of them is late or both of them is early, so let's take, this is 10 a.m. For 30 miles, it was late by 10 minutes. So for 30 miles, it was late by 10 minutes, that is 9:50. Okay, for 30 miles per hour, because 10 minutes. And if at 40 miles, instead of early, it was late, so late plus late, late plus late. So at 40 miles, at 40 miles, it was late by 5 minutes, so it reached at 9:55. So when both of them are late, what is the time difference here? That is 10 minus 5, that is 5 minutes. So your time will be 5 minutes. Similarly, if both are, uh, sorry, both are early, sorry. This because they're coming early, so early plus early. That's why we are taking this. So if instead of coming late, it is coming early by 10 minutes at 30 miles per hour, and at 40 miles, it is coming early by 5 minutes. So the time difference will be 10 minus 5, that would be 5 minutes. So what we can write from here is early plus early would be subtraction. So sign would be changed. Instead of plus 10 minus 5, that would be 5 minutes. And we can convert this 5 minutes into our, we can write it by 5 by 60. Similarly, if they are late by, if the same question was there, and if they are late by, first they are late by 10 minutes and they are late by 5 minutes. So what we're gonna say here is for 30, 10 minutes, so 10, 10. And if 40, that was 5 minutes late, so 10, 0, 5. So still the difference is how much? 10 minus 5 is equal to 5 minutes. So late, both of them are late plus late. What we're gonna do here is we will subtract both the time. So 10 minus 5. So this is 5 minutes. So always remember, when both of them are opposite, are different, late early or early or late, then the time will get added. And when one is early, when both of them are early or both of them are late, then the time get subtracted. You can remember this. I think 3 or 4 years back, they asked this question. I still remember most of my students were unable to do this question. Now let's move on to the next question. So it is a similar type of problem, but here, as we can see, one is late and one is on time. So as we know, late plus late is what? Subtract late plus late, and early plus early. Both the time get subtracted. And if one is early and one is late, then both the time get added. So here one is late and one is on time. So on time, then the difference is like if it's on 10 a.m., if you have to reach, and if you are on time, so this one will be 0 because you have reached on the time, because you are not late by any time. And if you are late, that it means that is 10:05, so 5 minutes. So from here to here, the time difference was 5 minutes. So we can say that T is 5 minutes. So now let's take the question. Stephanie covers a certain distance between his home and work on a bicycle. Having an average speed of 5 miles per hour, he was late by 5 minutes. So instead of 10 a.m., he reached at 10:05. 10 minutes, 10 hour, 5 minutes. So if it was 5 minutes per hour. However, if he traveled at a speed of, at highest speed, because previously it was 5 miles, if it traveled at 6 miles per hour, he would have reached on time. So the time difference is nothing. So 5 minus 0 would be 5. So time difference is, so t 5 miles minus t 6 mile is equal to 5 minutes, is equal to 5 minutes. So 5, and we have to find the distance in miles. So we'll convert, because the speed is given in miles per hour. So we'll convert this minute into hours. So 5 divided by 60. 60. So this one would be d by 5, because the speed is 5 miles. Because as we know, speed is equal to distance upon time. Time is equal to distance upon speed. So time for distance would be distance. So we don't know the distance, so we'll keep it as d. And the speed was 5. For this one, d, and the speed was 6. Divided by 5 by 60 can be written as 1 by 12. So this one would be 1 by 12. So 6 5 is 30. So 60 minus 5d is equal to 1 by 12. So D is equal to, we'll take 30 on that side. So 30 divided by 12. Let's see if can we factorize it further. 15, 6, 6. So it will be 12 and 3, 2.5 miles. So this is your answer. So the distance in miles between house and work is 2.5 miles. In this question, the last question, it says that Emmanuel covers a distance of 30 kilometer at the speed of 6 kilometer per hour and a distance of 18 kilometer at the speed of 6 kilometer per hour. Further, he covers a distance of 16 kilometer at 4 kilometer per hour. What is his average speed? So if you remember in the first slide when I was teaching you the basics, let me go to that slide, first slide, here. As we can see in case 2, the, the, the distance was different. So in the question, last question, which we're solving right now, the distance are different, but time should be same to use these types of formula. But in that question, in question number 11, which we are solving right now, distance are different. Distance is different, but time should be same. Then only we can use that formula. But here there's nothing. This question is not talking anything about time, so we don't know anything about time, and we know the speeds, 3 speed, 3 distance, but we don't know anything about the time. So how are we gonna solve it? So what we're gonna do? This is first set of your information. So what is the formula? Time is equal to distance upon speed. So the first time should be how much? T is equal to distance upon speed, 30 divided by 6, that is 5. So what is the time taken to cover the second distance at a speed of 6 kilometer per hour? So T2, let's take it as T2, 18 by 6. So 3 times. Similarly, that it covers another distance, 16 kilometer at a speed of 4 kilometer per hour. So 16 by 4, that would be how much? 4 hour. So now we have to find the average speed. So that is going to be total distance upon total time. So total distance was first 30 kilometer, 18 kilometer, and then 16 kilometer. So 13 plus 18 plus 16, this 16 kilometer. And what is the time? So time for the first was 5, 3, and 4. So 5 plus 3 plus 4. So 16, 4, 8, 8 and 6, 4, 3 and 2, 1 carries, 3 plus 2, 5 and 1 carries, 64, 9, 5 plus 4, 9 and 3, let me see it one more time, 18 kilometer, okay, and 12 times. So what is 12? 5s are 60. So the approx value is something 5 point something. So we have to find the approx average speed. So 12, 5, 60 times. So something's around 6, 5.3, 5.4. So the approx value would be 5.4 because among the option only 5.0. So this is the end of this video. Now, these are 5 practice questions on the topic which I have taught you recently in this video. Do solve these questions to test yourself and write down the answer in the comment section. Students who will answer all the 5 questions correctly, their answer will get pinned in the comment section by me. If you like the way I teach and want to buy a comprehensive course for SAT exam at a very affordable price, that is at par with your SAT exam registration fee, you can check out our homeschooling SAT app and website. All the links are provided in the description below. One more thing, don't forget to like, share, and subscribe to this channel so you can get updates of upcoming free video that I'm going to upload on YouTube in future. Thank you very much. Have a nice day.